It really is. It's a huge honor to be here. I love coming to this conference. I feel like I learned so much. I'm probably the least capable R programmer in this room. And I love coming here and realizing everything I'm doing wrong. Like, I still set working directory, even though Jared tells me every time not to do that. So this is supposed to be a stump speech about my research on the stuff I'm doing using satellite imagery and machine vision, computer vision. But I want to convey something that I've learned about it through my research that are relevant for you guys. So I retitled this talk. So it was using satellite imagery and machine learning to estimate conflict in Syria and poverty in Mexico. I'm going to call this wild speculation on the future of data science from someone barely qualified with 2 applications. So, and I think really the only way in which I'm qualified, I think there's 2 qualifications that are important here, is that I'm tall and I'm Jewish. So, so this is of course from Jared's wedding. All right. So I do have some qualifications. I was hired by Chapman University after I finished off my degree, where I teach R and machine learning to MBAs and undergraduates. And in fact, I have 2 undergraduate students here. Where's Nancy and Andre? Nancy, where are they? Yay, they're back there. OK, so 2 undergraduates. Chapman flew them all the way out from California. This is the first time they've been in New York City. Nancy has a job, but Andre, you were still looking for a job. Is that correct? So if somebody is hiring an entry-level data scientist, I give my word that Andre knows what he's doing. So, I teach MBAs and undergraduates. But in my research, I mostly work in development economics. So I try to solve problems in development economics. And one of the problems that I focus on are data gaps. Data gaps are problems where we just don't know a lot about the developing world. And one of the startling statistics is that from the period of 2002 to 2011, there were 57 countries that just had 0 or 1 poverty estimate. And if you're somebody like me who cares about poverty and reducing poverty, the fact that we're just not measuring this at all should be very startling. And you'll see this throughout the developing world. We're just not measuring things that are very important. And so the reason why we don't do a good job of this is because it's really expensive. Like, you have to physically send somebody to someone's household. You have to interview them for an hour or 2, and you have to figure out basically how much income they have. Their areas could be located very far apart. And so visiting each household is very expensive. So even like a very large country like Pakistan, you'll survey maybe 20,000 households once every 3 or 5 years. And in fact, in Pakistan, there are places like Jammu and Kashmir or the Northwest Frontier Province where you just never send surveyors there. And another like startling fact is in Nigeria, we actually have no idea how many people there are. Like, estimates vary between 200 million and 140 million, because every time they try to run a census, the government just deletes a bunch of people because they don't want certain places to have more population. Like, it's just very startling. And so my work is about, a lot of it is filling in these data gaps. One of the more popular data gaps, ways to fill this in is, let's look at satellite imagery. So maybe some of you are familiar with this imagery. This is what, if you look at a satellite image at night, you can kind of tell, well, which one's North Korea and which one's South Korea. It's pretty obvious. North Korea is the one without any lights, so in case you're wondering. And that works really well for just kind of gross statistics. But we're looking to do something a little bit more with our numbers. And in particular, I'm interested in these, like, not just like these old-fashioned satellites, but I'm interested in these really like frontier microsatellites. So these are there's a startup called Planet that releases these like small satellites that are the size of shoeboxes, and they currently have 190 in orbit. They have more satellites in orbit than any other country besides the United States and China. And so they have daily revisit rate of all of the Earth's landmass. And you can start doing some really crazy things with this data. And we're just launching like a crazy number of imagery satellites. So if any of you are searching for a dissertation topic, this is probably something that, like what I did, I was just like, I have no idea what to work on, so I'm going to start messing with satellites, because there's probably something here. So previous work that I've done is I've tried to generate intermediate features from satellite imagery. So I use computer vision to extract out the number of cars, a number of buildings. So this is a raw satellite image of Sri Lanka. I ran kind of like an off-the-shelf computer vision algorithm against there. I could figure out the number of buildings, and I could figure out the number of cars, and I used R in order to just pump that through and build a prediction model of the amount of poverty in an area. So to push that a little further, I wanted to see, like, could I do this directly from daytime satellite imagery using the fancy new stuff, the convolutional neural networks directly? And you can kind of tell, like there's a lot. So if we look on the left, we see that this is a very well-off area in Mexico City. So this area has like large streets. It has a lot of green areas. On the right, this is a poor area. Buildings are more irregular. They're a little more closer together. The streets are kind of crappier. And then the poverty rates are accordingly. So in the previous work, I tried to tell the computer what are the poor areas, what are the rich areas. So now I'm just asking the CNN to figure out what are the visual features that the poor areas have. And this is like this is a really hard task to do because there's just not a lot of data. So we're trying to do this at the municipality level in Mexico, and there's 2,500 municipalities. So this is very hard. And so a lot of people would say this is impossible. So we're going to do transfer learning against this. So what we're going to do is we're going to take like an off-the-shelf CNN model, which truthfully I don't even understand this. Like I understand the endpoint. All this is pre-trained using ImageNet. So it's been seen like millions of images. It's learned like all the intermediate like weights effectively. Or excuse me, Jared, those are coefficients, right? Yeah. Yes. OK. So we're going to learn all these intermediate weights. And at the end, we're just going to replace. Whereas this whole network is trying to figure out like if it was a car or maybe a cat or a dog or a hot dog, we're going to replace that last layer and just say, try to predict poverty. Like if you learned all these intermediate things that are useful for figuring out a hot dog or not, and now you're going to figure out if it's a poor neighborhood in Mexico or a rich neighborhood in Mexico. And so this part was not done. This was done in Python and Theano. And yeah, some details on Mexico. So we're using 2 poverty levels, kind of severe and moderate poverty. And then we do some nice withholding of 10% municipalities. But we're training this off of 900 municipalities. These are the only municipalities that are surveyed by Mexico. It's supposed to be representative, but that's a separate story. And so we trained on 800 of these, and then we're going to see how it performs in the test sample. So let's look how it performs. OK, so it's not a perfect fit. So we get R-squareds between 0.4 and 0.5. But still, this is better. Like imagine in a country where you have no data whatsoever. So this is, so let's see if there's something else we can do. So we also can do land classification. So we could look at we could ask to train a classifier and say, OK, what type of area is this? Is this a road? Is this a building? And I think this is super cool because we trained this against the planet satellites. So this is daily revisit rate, meaning that this is every road in Mexico. And if you want to throw this algorithm against new planet images, you calculate the changes in roads for Mexico. And you can do this anywhere in the world. So I just think this is like loads better than trying to do surveys. And then if we include this land classification in our model, it improves it a little bit. And we get these predicted poverties for urban areas in Mexico. OK, so what's the lessons we can take away? Like, I think a lesson here is that, like, using off-the-shelf data, like if you were just sitting in your R console trying to estimate something, there's this concept in economics, like the efficient market hypothesis. So, like, if a data set is out there, there's probably somebody who has mined it to write their dissertation or to do some analysis. So, I think, like, if you're in a field where you're trying to predict something in the real world, and you're using the same data that everyone else has, like, you're probably not going to do better than them, or better. And the way you really get an edge is by just generating some data that somebody else doesn't have. So you probably don't have to go to the lengths that I'm going to, but like just try to get some new data. And in many cases, generating new data or getting some new data is going to be better than using a better algorithm. OK. So the second project I'm going to talk about is really, really recent stuff. The motivation here is we have a lot of information on where violence is occurring in the world. But that information is biased, it's outdated, and it's imprecise. So it's a lot of the information on violence, it's recorded either by hand, so that there's some eyewitness who says, like, there was a violent event here in Syria in this location. Or it's actually recorded from YouTube videos, because every Syrian army has a YouTube video where they post and say, we bombed this building. And so we actually don't know the full extent of damage or violence, because maybe there could be delay when the videos were posted, or maybe there's some bias in just what was reported if somebody was there. And if you think about this, the point of bombs is that they're supposed to do some type of damage. That should be visible from space. So this is an area in Homs, Syria, and you can see that there's some detectable damage from these bombs. And so we can utilize some of the same computer vision technologies, and we can utilize that same technology in order to tell whether an area is a destroyed building or not. And this is the dream, is that you're running this in real time. So this is running on daily updated satellite images. And we're far away from that, but we're inching towards that goal. So we located 380 training sites in Syria with visually identified building damage. And we eventually want to increase this to 1,000, but right now this just shows 380 locations. And then we do this process of data augmentation, which is cropping and stretching and skewing the images. That increases this to 5,000. So we have about 5,000 images to train off of. And we're going to train 2 classifiers, one for this planet, fastly updated imagery, and the other one for the Google Maps API. OK. The labeling process is pretty straightforward. We just pull up some image in Google Maps. We're taking 1250 by 1250 images. And then the label, we just try to figure out what do we think is a destroyed area. And so anything that's a destroyed area gets a 1, and everything else gets a 0. And we're going to ask the CNN to try to figure out some type of mapping between those two, some visual mapping. The architecture is going to be, we're kind of starting from a place where we're using a building architecture. This has been used to detect buildings. So it's kind of this fancy sandwich of things that are happening in the CNN. And if you do computer vision, there's 7 CNNs that are stacked against each other, and then we take output for the 1st, the 2nd, and the 7th, and use that and create a stacked feature map to do pixel-wise. So the end result is we get a pixel that says whether it's a destroyed building or not. We do some advanced stuff, because that wasn't working out too well. So I talked to my people who really do computer vision, because I'm an economist, believe it or not. And they say, no, you want to use this UNet architecture. So we kind of make it a little more fancy. All right. Training notes. All this is done in Theano. It's run off Microsoft Azure's server. Where's Mark Weisman, who was saying, Mark, you were saying, you're right. Microsoft Azure platform is really fantastic. Yeah, it's really fantastic. It's super expensive, though. So I'm burning through money. I'm spending $1,000 a month. So if you have credits you can give me, because AWS they offered me $30,000, and I really don't want to take my research. We'll talk. Okay. Can we talk online? No, but he's absolutely. I'm giving him a hard time, but he's absolutely right. It's a great platform. You can load up a virtual server, and so we have 2 K80 GPUs, and it takes about 4 days to run, but we're able to estimate the model in that time. And so all this we're all working off of a $20,000 research grant from Lakeisha, and it's kind of, we started this 6 months ago. So, and we can see the preliminary learning. Anything that's red is a building. Anything that's not, or anything that's red is a destroyed building. And we see it's kind of learning that things towards the top right are destroyed buildings. kind of starts out thinking everything's a destroyed building, then it stops. And then the final, after 800 passes of the data, we get something that sort of closely approximates the input. And you could say, like, every data scientist here is saying that's super easy because that's an in-sample. So we can look at some of the out-of-sample results, and they look pretty damn good. So they're not perfect. We're still, we're working through the training data, and the more training data we throw into it, the better. But they look pretty damn good. If you care about confusion matrices, you can, but roughly we're getting about 90% accuracy at the pixel level. So next steps, we really want to use this to predict refugee flows. So this is where we're actually economists, is we're going to look at this from like a microeconomic standpoint. People are making decisions about where to go on the basis of, is there safety in certain areas? And so we have microeconomic models that are going to predict where somebody travels to. We want to also analyze reporting biases for different type of conflict. And yeah, so what's the lesson here? So this is actually backwards. So the data, we're building our models, and like a lot of our statistics has been based around static data. Data comes in, you get a CD, you get some thumb drive, it comes in, and we're building our data off of that. We're building our models off that data. And our whole project was on the idea that like data is going to be coming in real time. And we want to build our models that are going to incorporate that. And so maybe the goal here isn't necessarily to build the best model, to build something that is useful for people on the ground, for humanitarian workers. And so I got this completely wrong, because so really dynamic models are going to be better than static models. A static model is going to break if it sees stuff in real time and it's not able to adjust. So completely opposite lesson here, but OK. All right, so that's everything I want to present. So any comments or suggestions are appreciated. If you want to give me money, research money, that's great. Or if you want to talk to me about group lasso, because I've got a project where I'm doing some group lasso stuff. OK. All right, thanks so much.